Hello students, today we are going to discuss the flexibility method. This is the one of the most recent method of the analysis of structure and is very accurate method. Now, in this method, the basic unknowns are forces. Similarly, in the stiffness matrix method, the basic unknowns are displacement, but in flexibility matrix method, the basic unknowns are forces. Now, flexibility matrix method is based on determination of static indeterminacy, that is DS. We need to calculate here the degree of static indeterminacy of the structure, and this method is suitable when kinematic indeterminacy is more and static indeterminacy is less. Now, the steps which we are going to use in the flexibility matrix method is, the first step is determine the degree of static indeterminacy for the given structure. I had made a beam here whose support A is fixed, B and C are hinge. AB span will carry a uniformly distributed load of intensity W1 and BC span will carry a point load of W2. Now we need to find here the degree of static indeterminacy. So for vertical loading there will be only 4 reaction acting on the beam, that is 2 at A, 1 at B and 1 at C. So for the calculation of degree of static indeterminacy, the formula is R minus S and the value of R here is 4, and for vertical loading in beam the equilibrium condition will be equals to 2. So the total degree of static indeterminacy will be equals to 2. Now here we have to select the unknown forces, and in this beam the unknown forces are moment at A and moment at B are unknowns. Okay students, that is the first step for the calculation of static indeterminacy for the given structure. Now second step is select the unknown forces and assign them different coordinate number. We have already selected the unknown forces, that is MA and MB. Now we have to assign the coordinate number to them. So we will assign the coordinate number 1 at support A. Similarly, coordinate number 2 at support B. Now the third step will be remove all restraints, that is indeterminacy, and get basic determinate structure. Now we have to remove all the restraints and we have to obtain the basic determinate structure, that is the simply supported beam. So we have break this whole beam, that is ABC, into two parts, that is AB as well as BC, and these are the basic determinate structure because these are simply supported beam. Now we will mark the coordinate here, that is 1 at A, 2 at B. Now the next step will be obtain the value of displacement in the coordinate direction due to given loading condition in the basic determinate structure. Now we have to obtain the value of displacement in the coordinate direction due to given loading. Now we will find the maximum mid-span positive bending moment in both the spans. Okay, now we know that in case of UDL its value will be equals to WL square by 8, and in case of point load acting at the center its value will be equals to WL by 4. On putting this value we will get the Mx for span AB and for span BC. Now we will draw the MS upon EI diagram and we can determine the reaction at A, reaction at B, reaction at B and reaction at C. Now for the calculation of delta L1 we need to use the reaction at A. For the calculation of delta L2 we need to use the reaction at B for span AB as well as for span BC. From these two reactions we will calculate delta L1 and delta L2. Now assemble the flexibility matrix by applying unit force in the coordinate direction. Now we have to assemble the flexibility matrix by applying unit force in the coordinate direction. It means that we have to apply the unit force in the coordinate direction, then we will be able to determine the flexibility matrix. Now next step will be apply the compatibility condition to generate the flexibility equation in the matrix form. Now we know that flexibility is inverse of stiffness, so we can write P into delta is equals to the deflection. Here P is the force applied, delta is the flexibility matrix or flexibility, and deflection will be shown here. Now if delta L, that is displacement in the basic determinant structure, is given, as well as delta, that is displacement in the structure due to external loading, is given, then we need to modify this flexibility equation, and this equation will becomes P into delta into del minus del L. Now we have modified the equation. Okay, here we had written del minus del L. Now in matrix form we can write this equation as matrix P into matrix del equals to matrix del minus del L. Now one note is there, in case of bending we have to take the P as movement and delta as rotation because it is the displacement, but in case of bending we have to take this as rotation. Now after solving this equation we will determine the value of matrix P, which is the unknown forces for the structure, and we will completely analyze that structure and determine the value of different forces that is unknown in that structure. Thank you very much, students.